Okay, so we've been told that distilled water or deionized water, pure water, whatever you want to call it, cannot conduct electricity. Can't do it. Not going to happen. So, is that really the case? Well, boys and girls, let's find out. We've got ourselves a gallon of distilled, which, if properly distilled, is going to be more pure than deionized, because obviously your deionizing process is electrical, while your distilling is, well, you vaporize the water, you capture the vapor, you condense it, and what you're left with is pure H2O, supposedly. According to our friends Peter and Pete, water is not H2O. So, as you can see, it has not been opened yet. Still intact. I have not done anything to this bottle, so as you can see. So, what do you say we crack this bad boy open and begin our little experiment? And you all have to forgive my very atrocious videography skills. I don't do videography. I am an experimenter, not a videographer. And our lab photographer couldn't be here tonight because, well, it's 1 a.m. and normal people are sleeping. Okay. That ought to be enough. Yeah. Alright, so we have a decent amount of distilled water here, and of course I did clean the tray thoroughly for this to avoid any unnecessary contamination of our sample here. So, and we have our beginning test source here, 3 AAA wonderful, more or less charged Everetties. It's actually my light, but it also makes a good battery holder, so I'll be using that for my first test here. And we're going, and yeah, don't pay no attention to that stuff. That's from another experiment that's completely disconnected. I don't want to lose it, so I'm going to be working around it. We go from our negative across to our bulb here. Okay. And let's see, we have a light illuminating directly from our positive over there onto this crude example of an electrode. I really don't know what this other thing is off of. I think it was a microphone clip or something. As you can see, we've got conductivity there. Well, doesn't look like we're getting much, does it? Make sure, yeah. Not a whole lot of action going on. Alright then. To be expected, actually. What do you say we crank it up a notch. What we have here is our prototype water fuel cell driver, or my fuel reactor driver. It operates off of, well, for now we'll be operating off of this 30 volt 800 milliamp DC battery pack, because there's no need for big voltages involved here when small voltages can be just quite as easily experimented with and the same results gotten. So this guy, we will disconnect our current power source here, and we'll switch over to the fuel cell driver. I can see the connections. Get in there, you. Darn it. This breadboard's a little old, so bear with me. It's getting a little hard to work with. Okay. And we have the output of our driver, which has been tied together for, this usually has 3 channels, but we will be combining them to increase our current a little bit. We will take the clip from the end of the electrode here and place it on the output of our fuel cell driver, like so. And we'll get rid of this guy. It's a 100 ohm quarter-watt resistor, just to avoid burning up my bulb. Okay, we are oscillating the driver. We have our circuit running from the ground of the driver into our light here, over to the water source, from the water source over to the positive end of our fuel cell driver. Now let's start this driver up and see what we can get. Being very picky here, getting me to tune this circuit. Getting this circuit into the right frequency is the key to getting its output stabilized. Okay, we are running at 3.7 kilohertz. Oh, look at that. What do you know? Move this back a ways. Isn't that interesting? Let me try retuning our driver a bit. Okay, so here's our distilled water. Here's our light. And as you can see, when I remove the electrode, the light is out. In the water, the light is on. Out. Light is off. In. Looks to me like our distilled water source is conducting electricity, folks. You know, I'm feeling adventurous. Let's add another LED just to see. Well, I thought I had more LEDs here. Should have a whole bunch. Just to see how far this will really go. Come out of there, you. Okay, now we have two. 1, 2. So, what's going on here? Well, whenever you've got a volume of water in a circuit like this, you cannot treat it as a conductor of electricity. You must treat it as a resistor. This is one of these. Right there. Right there, that little guy right there. Resistor. 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 That is the same electrically as that. Not that. No, not that. So, whenever you've got a circuit like our friend Peter and Pete, where they take a 240 watt bulb and introduce a huge vat of water, what you are in that fact doing is increasing the net resistance. And there is no such thing, well, not that we know of, as a perfect insulator or a perfect resistor. Not air, not a vacuum, not your cat, nothing that we know of is a perfect resistor. At some level of voltage, all things will break down to conductivity. In the case of our water here, it's probably a couple mega ohms of resistance. So therefore, you have to take into account your load and your resistance in order to compensate with voltage threshold. In the case, well, let's go ahead and measure it here. Why not? I've got the multimeter. Our water source is, well, I guess it would probably be a little more practical to do this test with the power off of the cell. About 4, 3, at least 2 or 3 mega ohms. So tell me, if the water cannot conduct electricity, therefore, how am I getting a resistance reading if it was infinitely resistive? You would be getting infinite resistance reading. Oh, there it is. Infinite resistance. Not infinite resistance. course, just for good measure, to make sure, show you that I haven't changed the water off camera while the iPod here is zooming around all crazy. Let's go back to our original setup. Don't want there to be any room for question here. I don't have time for lies. I don't have time for funny games. Truth. I seek absolute truth, whether or not it's convenient. Okay. Here we are again, back to our original setup. We got our, let me get this back where it's supposed to be. We got our yellow going to our ground, up and over to the bulb again. From the bulb through our little resistor over to our first electrode, to our water, back again to our other electrode, back over to the power source. And as you can see, like before, same water, hasn't been changed in any way. 3 volts, the light, the water. Same reaction. It's not about what's in the water. It's all about resistance, threshold. There is no such thing as a perfect insulator. There is no such thing as a perfect resistor. That's all I've got for you guys.